Okay, so this is 2018 Leaving Cert Ordinary Level Paper 2, question 7. So we'll start off by reading the questions. So the table below shows total rainfall in millimetres and the total sunshine in hours at Valencia, County Kerry during the months of June from 2001 to 2010. Okay, so Valencia in Kerry in June, and that's each year. Okay, based on the data in the table above, write down the range of the rainfall data. Okay, so we're looking at the rainfall data. Okay, and they want us to find the range. So we should know that the range is going to be the biggest minus the smallest. So in this case, the biggest is going to be 155 and the smallest is going to be 47. So 155 minus 47 will give us an answer of 108. Okay, so our first answer there is 108, and that's in millimetres. Okay, the second question, based on the data given in the table above, the year with the highest June rainfall. Okay, so the highest rainfall in June, the highest rainfall was in the year 2003. The answer there is 2003. The year with the least June sunshine. So the year with the least sunshine, so 150 is quite small, 124, there doesn't seem to be anything less than 124, so the year with the least sunshine was in 2002. So that's part A. If you got that much correct, that was worth 10 marks that year. So, part B. Based on the data in the table, write down the year with the best weather and give a reason for your answer. So the year when June had the best weather. So obviously we need to look at the table for that. So what we'll do is we'll just look at the table there and we'll just analyse that, right? So which year had the best June weather? So obviously to have the best June weather, you'd need low rainfall and high sunshine. So low rainfall, high sunshine. Is there any other ones? So the lowest rainfall was in 2006. The highest sunshine was also in 2006. So there's no argument that 2006 had the best weather. 2006, and the reason is that year had the least rainfall. And the most. And the most sunshine, and we could say that's in the last 10 years. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. And if you got that correct, that was worth 5 marks that year. So now part C. Part C, write the rainfall in increase in order and hence find the median of the rainfall. So in order to do that, we need to take the rainfall and we need to write it from smallest to largest. So that's going to be 42, or 47 I should say, 72, 84, just tidy that up, 84, 94, 94, 101, 133, 134, 149, and 155. Okay, now I've arranged the data. I'm just going to go back and make sure that I have everything included there. So let's just tick them off to be sure, and you should always do this when you're doing it yourself. So 47 is done, 72 is done, 84 is done, 94 is done, 94 again, 101, 133, 134, 149, and 155. Right, so I know I've got all the data in, so that's perfect. So the next thing I need to do if I'm finding the median is I need to find the middle value. So when I'm looking for the middle value, all I need to do is not go after the smallest and largest, get rid of the smallest, get rid of the next largest, get rid of the next smallest, the next largest, the next smallest, and the next largest. And you can see there that I'm left with two numbers. When I'm finding the median, it's always, median obviously stands for the middle, okay? So the middle there is going to be these two digits, right? So what I'm going to do is I'm going to find the median by adding the two of them together and dividing by 2. So 94 plus 101 is going to give me 195. So to find out what the middle of those two numbers is going to be, I divide by 2. And 195 divided by 2 leaves me with an answer of 97.5. Okay, so my answer in this case, I was trying to find the median amount of rainfall, so 97.5 millimeters. Okay, and that question there was actually worth 10 marks. Most of the marks there, so the marks there would have been lost if people weren't able to find the middle of these two numbers. And anytime you've got two numbers that you need to find the middle of them, you just add them together and divide by 2. So, part D. Find the mean number of sunshine hours for June in Valencia between 2001 and 2010. Okay, so we should know what the mean is. In order to get the mean, what you need to do is you need to add up all of your inputs and divide by the number of inputs. So what that means is we need to add up all of these here and divide by the number of inputs, and the number of inputs you can see there is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we need to add them up and divide by 10. So let's do that now. Okay, so you can see there that what we've done is we've added them all up and we divided by the number of inputs, which is 10. So when we tie that up, we get 1,818, all divided by 10, which simplifies down to 181.8 hours of sunshine. So my answer was 181.8 hours. And that there was worth 10 marks that year. So, D part 2. It asks, for what year was the sunshine data within 5% of the mean number of sunshine hours for Valencia? So, in the last part of the question, we worked out that the mean sunshine, was 181 hours, 181.8 hours, I should say. Okay, so they want to know for what years was the sunshine within 5%. So I need to know a 5% more than 118.8, and I need to know 5% less than 118.8. So I can start off by finding out what 5% is. So I had 118. 181.8. If I want to get 5% of that, I just multiply it by 5%. So multiply it by 0.05. Because we know 0.05 is the same as 5%. And that will give you 9.09. Okay? Just make a note there, if anyone's unsure, 5% is 5 out of 100. If you type 5 out of 100 into calculator and press the S to D button, it should come up as a decimal as 0.05. So I need to know 5% less than 181. So 181.8 minus 9.09 gives me 181.8 minus 9.09. It gives me an answer of 172.71, and 181.8 plus 9.09 gives me 181.8 plus 909.09. That gives me 190.89. Okay. So what I need now is I need to bring back in that chart and have a look at it. And I need to see the values that fall for sunshine. So we're looking at the sunshine. So again, it's the ones that are highlighted blue. And we're looking for what years was the sunshine within 5%, okay? So we need to know when it was within that 5%. So anything greater than 172 and anything less than 190. So let's look there and see. So we'll mark these, we'll circle these, I suppose, as we go through them. So if it was greater than 172, but less than 190, then I'll circle it. So greater than 172, greater than 172, less than 90. So this one will work. This one will work. Greater than, this one will work. This one is too big. So that's more, this here is more than 190, so that won't fit this description. This is too small. This is too small. This is too big. And this is too big. So my answer there will be 2003, 2004, and 2005. So we'll just put that in. The answer will be equal to 2003, 2004, and 2005. And that year, that was awarded 5 marks. Okay, so the next part there asks us to find the standard deviation of the rainfall in millimetres, obviously correct to 1 decimal place. Okay, so we have all of the rainfall along here, and we could use the formula and stuff to write this out, but for ordinary level we don't actually need to. We just need to be able to type it into the calculator. So what we'll do is we'll just turn on the calculator, press the AC button to make sure everything's clear, and then we're just going to input this information. So press the menu button, and we know we're dealing with statistics, so go across to statistics, which is option 2. Press equals to get into that. When we're looking for standard deviation, we're dealing with just one variable, so we're going to pick the first option there, which is just 1. Then it gives us the option here to input information. So I'm going to input all my pieces of information there. So I'm going to start off with the first piece of information, which is 72. To get that in, I just need to press equals. This next part there is 133. So I'll put that in, 133, and press equals. The next part is 155. So 155 and equals. 101 and equals. 94 and equals. 47 and equals. 149 and equals. 134 and equals. 94 and equals. And 84. And you can see there, it even tells you that that's 10 pieces of information. So we know that we've everything put in. Once we've everything put in, we then press the options button. So the options button here. And again, we're doing one variable calculations. So you go to option 3. And that will give you everything there. So that actually tells you can see there, the first thing it gives you is the mean, which is 106.3. Okay. Sigma x, okay, is our standard deviation. So you can see there that it's 33.4605. So we'll just fill in there that sigma was equal to 33.4605 7381. Okay, and it asked us to give that correct to one decimal place. So we'll go back one decimal place, draw an imaginary line, look at the number that follows. So in this case, our answer will be equal to 33.4, and that is in millimeters. This year in the exam, they allocated that 5 marks. So if you got that correct, you would have got 5 marks in the exam for that. Part F. Part of the scatter plot of the data in the table is shown below. The first 4 points are plotted. Complete the scatter plot. Okay, so you can see here that we've some information plotted, and we can see that what we're plotting is the total sunrise in hours against the total rainfall. Okay, so we'll just have to bring in the chart again so that we'll be able to see how that correlates to what we're looking at, right? So what we have here, so let's just have a look and see, is there an obvious enough point? So let's just go to total rainfall being about 150 odd. So 150 odd, and that maps onto 180. So you can see there that point is plotted already. So we'll just tick off the ones that are plotted, because then we won't need to plot them, right? So, well, we'll just start at the very beginning. So 72 for rainfall. So if we go to rainfall for about 72, so it'll be about halfway, and up, okay, be about here. 72 up 169, 170. So that one seems to be done. Okay. So the next one, if we go to the rainfall again of 133, so 133 I'd expect to be around here. Okay, and if we go up 124, so we can see that one's actually plotted as well. So that's perfect. The next one, we'll go to our 155 on the x-axis, so 155 would be about there. Does that correlate to 180? It does, that one's done. The next one, 101, so 101 would be around there, up and across, and that's 170 odd. Yeah, so that would be about right. 194, so that's the first 4, as they said, plotted. So now we start plotting our own. So 94. Okay, so halfway between the two of them would be 90, so slightly over, a little bit more than halfway. And if we go up 173, so 170 be halfway, so 173 would be about there. Okay, so I'm just going to keep that there for a second, and it is around there, we said. Okay, the next one, 47, okay, and 239. 47 would be about here. 239. 239 would be about there. Okay, so we're looking at around here. The next one, 149. 149 would be somewhere on this axis. Okay, so 149 would be around, 149 would be close to 150, so we're about halfway on this. And 160 is what we're looking for on the x-axis, so about there. Okay, the next one is 134. So if we go to 134, so 130 and a little bit more, so halfway between the two of them, I'd say. And if we go 168, and 168 would be about there. Okay, so we're looking at about there. For 94, 94 and 228, so 94 would be around here, and 228 would be around here. Okay, and 84 and 205, so 84 and 205, 84 would be around there, 205 would be around there, so we're looking at somewhere in around there, you could say. So just for plotting that, there was 10 marks going for that question. So the final part of that question there is part 2. So one of the numbers in the table on the right is the correlating coefficient for the data above, correct to one decimal place. Based on the scatter plot, select a number that you think could accurately reflect this data, okay? So basically it's just the correlating coefficient. What that means is the slope, okay? So in order to see what the slope of a line of best fit would be, I need to bring back in my scatter plot and I need to have a look and see where I could put a line of best fit, okay? And if I was looking towards getting a line of best fit, I'd need to get roughly 5 on both sides. So if I was to do that, what I would do is just have a look there and see. So maybe around, it's going to be somewhere around there, you could say. Okay, so it's going to be tight. You can see there you've got 4 on the bottom. You've got one of these, you could say either side almost. So let's just bring that. If you were to bring that down a small bit, you'd have something that looks like that, okay? So the main thing is we need to try and find the slope of that line. What do we know about it? Obviously this is all rough. We know that it's a negative slope. Okay, so it's going to have to be one of the bottom 2. Okay, and it's either going to be negative 0.1 or else it's going to be negative 0.6. So going on a process of elimination, I would imagine that 0.6 best fits the correlation, okay? Now, the reason behind that is because negative 0.1 is very, very, very slight. Negative 0.1 would be, you have to go across 10 boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You'd have to keep going and you'd only rise up 1. So it's very, very slight, whereas this is a small bit stronger. So now that we've picked the correct option, we just need to fill in the explanation. So the reason is correlation is negative. And relatively strong. And if you wanted there, you could say that the rise over the run is equal to 1 over 6 over 10, I should say. Okay, so for every run of 10, it goes up 6. And had you said that year in the marking scheme, that was worth 5 marks.